Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss the concept of discharge, work done and power required to drive a double acting reciprocating pump. So in our last lecture, we have discussed about the single acting reciprocating pump. So now we'll see the working principle of double acting reciprocating pump. Along with that working principle, also we'll derive the equation for discharge, work done and power. So first of all, we'll try to understand how it is working. So we know that the reciprocating pump is a positive displacement pump. So this is quite normal, like simple things. It is a, we can write, it is a positive displacement pump. Just I'm writing the short form, but we need to write fully positive displacement pump. So here also we'll see what are the equipments are there or what are the components are attached in the pump. So in the single acting reciprocating pump, all the things are single only, like suction pipe was one, delivery pipe was one, suction valve and delivery pipe valve, all these things are single are there. But here in the double acting reciprocating pump, we have all these items are double is there. So the first one, I'll tell you that components are which are used in this. Then we'll see how it is working. So in the components, we can write what are the components are used here. The first components, let me write the cylinder. So first component we can write cylinder. Along with the cylinder, also I can write that piston or piston rod. We can write another one component, like here. This is piston and piston rod. So this is the second component. Similarly, along with this also you can write that connecting rod is there, and crank and connecting rod, that is crank mechanism actually. So we can write that is connecting rod and crank. Okay, and apart from this we have, like you can see, suction pipe. This is the suction pipe and this is the suction pipe here, because double is there, that's why two are there. And here suction valve, this is suction valve, this is delivery valve, and this is delivery pipe, and this is delivery pipe. Okay, so here we can write, like we have two suction valve and two suction pipe. Similarly, we can write, we have two delivery valve, and two delivery pipe. Okay, so these are the components are there in this double acting reciprocating pump. So let's see how it is working. Okay, suppose let's see, this is our cylindrical part is there, and in that let's suppose this is cylinder is there. Okay, and inside the cylinder, this part is our piston part. This part is piston, and this is our piston rod. This is our piston rod, and this is connecting rod. The connecting rod is connected to the crank. So suppose the crank is connected here. Okay, and it will have a circular, you can see, suppose this is the center point, and you can draw like this. Okay, how it is moving, that depends. So let's see, this is our, as I told you, piston rod, okay, connecting rod, and this is the crank. This part is the crank. So how it will work actually, I'll tell you the in the last class also I told you, like how is the single acting reciprocating pump is working. Same methodology here. Okay, but we have connected another one label here, another one side, in which also will take the advantages of this, like forward and backward. So actually here in this double acting reciprocating pump, the water will be delivered during forward stroke as well as the backward stroke of the pump piston. So this is the piston is there. We know that how it is working. Suppose this is the sump label or reservoir is there where the water is stored, and we have the P atmospheric will be here. Okay, so when the crank will be started, the crank will be connected, this crank will be connected to the motor here. A motor will be connected here. So when we'll start the motor, then with the help of motor, the crank will be started. So when the crank will be started, the connecting rod will be started moving, and the connecting rod is connected to this piston rod. So, and it is connected to the piston. So suppose initially at this point that piston is present at the first position, piston is there, and this is the second position. Okay. Now initially we have the normal condition, like this is our piston rod, and here connecting rod, and this is crank is there. Okay. Now at this point, that means in normal condition is there. Suppose this is okay. So how will get the circle? This is the circle point. Now when it is started, the crank is started, so it will start moving, like it will start rotating here. In this way it will start rotating, correct? Then it will come here. That means if you see from 0 degree to here, see 180 degree, the crank rotated here. Once it's rotating, in the sense the piston also will be, what will happen, this piston will be moved up to here, up to this point, that means up to second point. So the piston moved from, this is our left side, suppose from left to right. So the first position at this forward, if you see, that piston moved from 0 degree to 180 degree. That means this is the, suppose if you consider this is the forward stroke. Okay, this is our forward stroke, suppose. Okay, in the forward stroke, what will happen? I'm talking about single one, then you can understand for the both, like double, how it is working. So in the forward stroke, the water is lifted here. Okay, the water is lifted, and by the meantime, due to the pressure difference of the inside and outside, like atmosphere pressure and this is suction pressure, both are having the difference. And here atmosphere pressure is more, suction pressure is less. So the water will be started lifting here, and the water will be filled at this point. So when it's moving here at the second point, this is full of water will be there. So this is forward stroke, correct? Now, so again, the connecting rod, the crank will be started moving from 180 degree to, now see, this is 180 degree to 360 degree. Okay, this is 180, this is 360 on 0 degree. Now again, it will come from 180 to 360. That means from right to left. This is backward. This is called backward stroke. Okay, so in the forward stroke, actually, as I told you, forward stroke, the water came to inside here. Okay, meanwhile, actually, when it is moving forward, in here also again the water will be moved here. But how the water present here, I'll tell you here. Actually, here also the water will be filled in this position, because here also we have the suction pipe. So when it is at this point, means already it was taken water from this side. Okay, that's why it is filled of water. And when it will come to this side, that means in forward direction, at the forward direction, the water will be compressed and it will go out here. Okay, and when it will come, the piston will become from 1 to 2 position, then this will be filled of water, this will be delivered, this will be delivered, this will be suction. And again, from, like as I told you, 1 to 2, again here 2 to 1. And when it will be in the backward stroke, that means the piston moved from second point to first point, that is backward for this one. And meanwhile, this will be sucked, this will be delivered. Okay, like that work will be happen. So that means the water will be delivered through this, okay, and through this also. That means what I mean to say here, 2 suction stroke and 2 deliver stroke. Okay, so when we can say, when there is a suction stroke one side, if you take one suction stroke for one side, one suction stroke at one side, the other will be the other side. Okay, okay, the other side will be deliver stroke. At the same time, the other will be acted as the deliver stroke. And when the other side is suction stroke, when, okay, one suction stroke is other side, like one side we can write like this, other side is deliver stroke. Okay, and similarly, suppose we can write here other side in the one side, in the sense first, other side means we can consider the second one. Okay, similarly, other side is suction stroke, other side in the sense second side. Then in the one side or in the first side, we have the delivery stroke. So this is the method of working here. Okay, so I hope you understand. It's very, very simple. Only in the single stroke, only single pipe, single delivery pipe, single suction pipe, single valve, single delivery valve, suction valve are used. Here both are used, two are used. So that in the moving, like in the forward condition also, will make it deliver, and here will be suction. Okay, here it will be delivered, here it will be suction, and when it will be suction, this side will be delivered. That is the concept. Okay, so for complete one revolution of the crank, there are two delivery strokes. Two delivery strokes will be, the water will be delivered. Okay, for complete one revolution. If you see now what I shown you from here to here, when it is coming 0 to 180, one delivery strokes. Like when it is coming from forward, one delivery strokes. Again one more stroke means, that means again half of the revolution completed, that is one more delivered. Okay, so for one complete revolution, two delivery strokes are acting, or two delivery things we are getting here. That is the working principle of double acting reciprocating pump. So along with that, we'll first identify the discharge point. Okay, first we'll try to deliver this discharge. So before calculating the discharge, first we need to consider some terminology here, as I like diameter. D is the diameter of piston. Diameter of piston. And similarly, the small d we can consider, which is diameter of piston rod. Diameter of piston rod. Now if you see at this point, try to understand, this is our piston, correct? This is our piston. This is one side, this is another side. In this side, if you see, there is no piston rod is connected, but this side we have a piston rod. Okay, that's it. So we need to find out area of piston, both side, one side, again second side also. So for that, what I'll do, for this, let me write area of piston, the area of piston, okay, of area of piston on one side, of single side. If you say in that side piston rod is not there, then I can write area equal to what, pi by 4 d square. Okay, now other side, if I consider area of the piston on the other side of the piston, other side in the sense this side, other side means this side, and one side is this one. Now same thing, let me write area of piston on other side. It is very simple. Okay, other side where the piston rod is connected. So in that condition, what we can write, so that one will write A1, suppose. Okay, A1 equal to, we can write pi by 4 d square minus this area will be subtracted here. So that is pi by 4 small d square. If I write this one in this form, like pi by 4 capital D square minus small d square. This is the difference. Okay, because here this piston rod is connected to the piston, and other side no piston rod is connected, so total area is this. Okay, now we need to calculate the volume of water delivered. Okay, the volume of water delivered. Let's close this. Volume of water delivered in one revolution of crank. In one revolution of crank. So this one, we know that how to calculate. This is nothing but very simple. In one revolution, like from here to total here, how much volume can be delivered, volume of water can be delivered. So that is nothing but we can write area into length of the stroke. Area into length of the stroke. But here it is two times happening. Single stroke, it is only single, like AL used to write. But here if you see one, like deliver stroke from here to here, one half of the stroke we used to get one delivery. Again half of the things, again we are getting one deliver. So two times we will write. So A into L plus A1 into L. Why A1? Okay, you can write A1 A2, or if you can write A and A1. Like if I mentioned here 1 and 2, so I'll write here A1 and A2. That also you can write, but here I have not mentioned, so let me write here. Otherwise, this is A2. Okay, like that also you can mention. So, now we can write this like A1L plus here. If I consider A1, okay, L I'll consider here this is not A1 plus A2, L take common here. Okay, let's take L common from here because length is fixed. How much distance from here to here? So A1 plus A2. So A1 plus A2, we know the formula. Already we got the value, that is pi by 4 d square. This is for A1. For A2, what is there? That is pi by 4. This is d square minus small d square. And yeah, this is the A1 plus A2. Let me bracket it into, this is L. Okay, this is the total like volume of water will be delivered in one revolution of crank, like from 0 degree to 360, like 90 degree, 180 degree, 270, then 360. Again, we'll come to the original position. Now we will find out the discharge. This is actually volume of water delivered. Okay, now how? Okay, this is the volume of water delivered, one revolution of crank, but in one revolution, number of revolution per second, because per second how many revolutions are happening, that we also need to understand. So okay, let me write first discharge. Yeah, so I'll start from here. So discharge, I can write the discharge of water, discharge of pump per second, discharge per second. This one we can write, this is the volume of water delivered in one revolution per second, that is pi by 4. This is d square plus here pi by 4 d square minus small d square into L into, along with this, what I told you, like number of revolution per second. Okay, number of revolution, like each second how many revolutions are taking this one. So that is how we can calculate, that is the speed of the crank with respect to second 60. So that can be multiplied here. So here if you see, the diameter of this piston rod is very small. Okay, so if you consider the diameter of the piston rod is very small, then that part can be neglected. So that part can be, that side can be neglected here. Okay, so this can be neglected. So if you neglect this one, then what will be the remaining? Pi by 4 d square plus pi by 4 d square. Okay, and then what will get here? Like 2 pi by 4 d square. 2 pi by 4 d square. This part I have cancelled here. This small d I have cancelled because I have considered this piston rod is very small. Okay, so we can cancel that. Into, this is ln by 60. ln by 60. Now here we can write ln by 60. This is what? This is our area. Okay, so we can write 2a ln by 60. This is our discharge. If you remember, in the single stroke, in the single acting reciprocating pump, we got Q equal to A L N by 60. Okay, but here we got 2 ALN by 60 because of two double pipes and double delivery pipe, that is double section pipe is there. Okay, this equation will give us the discharge of double acting reciprocating pump. Okay, now we'll go for the work done and power. Now next one is work done, okay, per second. Similarly here also work done per second. So how we can calculate the work done per second? So we know that work done equal to force into distance or force into displacement. So here the weight of the water delivered, the weight of water which is delivered into the total height. Total height is how much from here to sample level to total delivered height, how much is there. So that is distance we can write, or we can write the height of the delivered point. So weight of the water, how much we can write, that is rho g q. So I told you how we got this rho g q, also I have told you previously. And this one, the total height, we can write hs plus hd. hs plus hd, what? hs is the suction height, suction head. This is the suction point, hs. And from here to the height which is measured here, that is hd, okay, delivery head. So that is your total height. And rho g q, if you remember, I already told you, like we know that weight of water. What is the weight of water? W equal to, we can write mg, and m in the place of m we can write rho v. This is weight per second. So this is rho v into g per second. and this volume per second, that is volume per time, that is nothing but discharge. So we can write rho g q. Okay, so the same thing I have written here, and this is the work done per second, rho g q into this value. Now here we can write what is the value of q we got here, 2 ln by 60. So we can write 2 rho g into a ln by 60 into hs plus hd. This is our which equation? Work done per second. Now once you find out the work done per second, then it is very easy to calculate the power. Just you divide by 1000 to that. So the power required to drive the double acting reciprocating pump in kilowatt. In kilowatt we need to consider. So this one we can write, what the formula is there, work done per second by 1000. So okay, 1000 because of this kilowatt. So we can write this is rho 2 rho g ALN, and this is HS plus HD, bracket close, divided by in the denominator already we are having 60, so 60 into 1000, that is 60,000. Okay, so this is this much kilowatt of power required to drive the double acting reciprocating pump. So I hope you understand this concept of double acting reciprocating pump, and few differences there between the single stroke and the double stroke. Just I'll tell you orally, just you can remember this. For the single stroke, if you for the single acting reciprocating pump, what used to have only single stroke, but in the double acting reciprocating pump we are having both stroke, forward stroke and reverse stroke. Both in the both stroke will get the water outside. Okay, water will be delivered. So in the single acting reciprocating pump, the water may be that discharge may be little bit intermittent will be there. Okay, some kind of disturbance may be there, but in the double acting reciprocating pump will get continuous flow will be there. Okay, similarly in the single acting reciprocating pump we'll have one suction stroke at one delivery, but in the double acting reciprocating pump we'll have two suction stroke and two delivery stroke, and discharge will be more for the double acting reciprocating pump and less will be for the single acting reciprocating pump. And the design is a little bit complicated here. We can see more complex design for the double acting reciprocating pump. For the single acting reciprocating pump, it may be very simple, that we can write. Along with that also, cost also we can write, though you can see the complex design we having. So we can say this is the high cost and single acting reciprocating pump is less cost. So these are some basic differences and working principle of double acting reciprocating pump, discharge and work done and power required to drive the double acting reciprocating pump. So I hope you understand this lecture. If you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.